Right, we were talking about OSPF special area types. We even did two labs on two different types of special areas. One was a stub area, the other one was the totally stub area. When you configure an area as a stub area, type 4 and 5 are not permitted inside that area. The reachability to external network will be via using default route that is dynamically injected into all the routes in the area by ABR. So stub can reduce the routing table by stopping the external routes coming in. Now when you configure totally stub, your routing table in that area will be much more smaller because the other area routes along with external routes will be stopped by the ABR. So ABR will stop type 3, 4 and 5, type 3, 4 and 5 entering in. But we'll be able to ping other area routes as well as the external route using that same type 3 default route given by ABR. And this we have even tested practically. There are a few points that we need to remember when we are configuring stub or totally stub. What are they? That area should be with single ABR. If you have more than one ABR, you need to make sure the optimal path is only through one ABR. Secondly, we need to go to every router configure stub. Thirdly, you cannot have an ASBR in that area. Fourth, area 0 cannot be configured as stub area because it is a transit. And at last, you cannot have a virtual link passing through the area. Do you have any question on these things? That's great. Now we are into this topic called not so stubby area. Oh no, sorry. Where is that? Yeah. Right. So, not so stubby area. As you know, the area that is configured as a not so stubby area will only allow type 7. Actually, the ASBR in the not so stubby area will convert the type 5 into type 7. Right? So the type 7 is more than enough to bring the external network but the other ASBR's route won't come in. Type 5 is denied. Type 5 is denied. Type 4 is denied. But local ASBR type 5 is now converted as type 7. So you will have routes given by local ASBR. We are going to see that now in the lab environment. You see this topology here? How many ASBR we have? See, this router 2 is one ASBR. You agree? Because there is RIP here. Do you agree or not? Do you see? Do you agree? Router 2 is an ASBR. Okay.
Yes.
And then router 7 is another ASBR.
Yes.
After we configure this area, this router 2 is area 2 as a, after we configure area 2 as a stub, not so stubby area, you should not be going to this router to access this 11 network. Router 8 should not go to router 5, router 4, router 3. Instead, it should go this way to 7, 8, and 6. I'm going to do and show you that. First, what I'll do is, I'll go to 7, and when I redistribute, I'll increase the cost so that 8 will go via 5. If I increase the cost, what will happen? 8 will go via 5. Wait, let me zoom it and explain you with a picture. Snipping to. Focus on this, please.
Yes.
You see, when I redistribute, I'll give 100 so that this route will be seen as costly route. You understand? This will be seen as costly route, and these routers will try to take this path because of the cost. Why are we doing this? For testing. What we are testing? When you configure this as a not so stubby area, this router will take this path even though it is costly. Why? Because the path via this direction will not be available. Type 5 will be blocked. You understand? When type 5 is blocked, now there is no other option okay, there is no other option when you configure not so stub area. When you have no other option, then you have to go via router 7, which is the local ASBR. So when I make this path costly, before configuring NSSA, when I make this path costly, the traffic to the 11 network will go this path. But as soon as I put NSSA, this path won't be available because type 5 coming in is blocked. So these routers are left with only one option. What is that? To use local ASBR, which is also giving external route, but in the form of type 7 instead of type 5. So in the routing table, you will see N instead of E. The type 5 learned routes will have E, external. Type 7 learned route will be having N. N means what? Not so stub area. Shall we test these things?
Yes.
Okay. Now, I'll go to router 7 first to increase the metric while redistributing. Show IP user show run section router OSPF. You see, I just did simple redistribution, but this time I'm going to say router OSPF1. I remove this, or I'll just add this line with metric. Metric 500. Because I gave metric 500, router 8, if you go and check, router 8 will not exit via router 7. Instead, it will go to router 5, 4, 3, 2, 1, which is in the left. Let us check it. Show IP route OSPF. I want to see E2 external. See? External says I'm going via 7. Surprisingly, it is going via 7 even though the cost is high, which means this route is still not coming for some reason. I need to check why. I want to troubleshoot. Okay, router 4, let me go and check whether it knows the route. Show IP route. Show IP OSPF neighbor. It has got neighbor with 5 and 3. Are they two neighbors? Correct. Show IP route OSPF. Okay. Even this is going via 5 only. The costly route. So for some reason, this route is not coming to 4. Let me go to 3 and check. I remember in the previous class we had some issue in forming neighbor. That is still there. Show IP OSPF neighbor. This is the problem. So between 2 and 3, something is blocking from forming neighbor. We are seeing this for a long time. Now I'll check show IP, show run interface G00. I can see OSPF area 1 correctly configured, and IP address is also /23 correctly configured. Now I want to do the same check, similar check on router 2. Show run interface G0/1. Here also the IP address looking good. This is good. Everything is looking good. But I'm not able to form neighbor. I remember the same problem was there earlier. But we need to see the reason why. Okay. G01 is in area 0, that is okay. This is in area 1. Let me try this G00 IP OSPF network type point to point. I will also do the same on router 2. No shutdown. Looks like the interface is not responding anything. Show IP interface brief. Show IP OSPF interface brief. I have point to point configured, and oh no, router 2 is not having OSPF. That's okay, the other side should not run OSPF. That's okay, but this side should be OSPF. Area 1. I said point to point also. No router OSPF 1. I think there is some router ID issues. I need to check the router IDs on this router. So I removed OSPF completely. I will also remove from router 3. No router OSPF 1. Now interface range G0/1 comma loopback 0 IP OSPF 1 area zero. Show IP OSPF interface brief. Okay, sounds good. This one is okay. Now going to router 2. Router OSPF 1. Router ID 2.2.2.2. Interface loopback 0 IP OSPF 1 area 1. Show IP OSPF interface brief. Okay. Even here I need to configure interface 0/0 IP OSPF 1 area 1. I'm expecting neighbor now. I don't know why this is not okay. At last we have got. Show IP OSPF neighbor now. Okay, it has come. Now if you go and check on R4 should not go to R5 to reach 11 network. It should go to router 3. Earlier it was going to, see the last number 5. Now I'm expecting 3. Now, even now it is going via 5. We need to figure out why. So going back to router 3 to check whether it learns from router 2. Show IP route OSPF. Now, this itself is receiving from 4. I think 2 is not giving. Show IP OSPF neighbor. It is a neighbor, but maybe redistribution is not done. Show IP OSPF neighbor. Yeah, redistribution I think. Show run section router OSPF. Oh no, that is the problem. Router OSPF 1 redistribute RIP subnets. Here I am not adding the metric. So the default metric will be 20. So the route given by router 2 will be the best. Let us check whether I am learning route from RIP. That is also a problem. So let us go and see show IP protocol. Do I have RIP running here? Yeah, that itself is a problem. Router RIP network 12.12.00 no auto summary version 2. Show IP route RIP. Maybe router, this router itself is not configured. Is that true? Let us go check. I thought I configured earlier in the previous class. Show IP interface brief. Okay, the interfaces are having IP. Show IP protocol. And we do run RIP. Then why? Go back to router 2. Maybe it took some time. It might have learned now. No. Why? Version 2 12 network. Oh, I know the reason. All right. But you know the reason why the routes are not coming in router 2 is administrative distance. You see, OSPF is bringing the route from right side, isn't it? Wait. Let me put one color. Let me put one color. Color green. These routes, no? Though it is coming from RIP, who is carrying it? OSPF, right?
Yes.
What is the administrative distance? 110. Correct. Now, the RIP is giving the route. What is administrative distance? 120. Will this router use it? No. So what I am going to do now, I am going to put RIP's administrative distance also as 110. I'll cut this 120. I'll make RIP administrative distance maybe lower. I'll say 100. You understand? So that this router will prefer this RIP route. And now when I redistribute that, it will go. You understand? Okay. So I repeat the scenario. When we check now in router, I think I have to. Right now, when we check in R4 or R3 or R2, it is only going via. Come on. It's only going via left. It is because of the RIP routes coming from router. RIP route that is learned in router 2 is not actively in use. Administrative distance matter. That's why router 3 is sending to 4 instead of 2. Now I'll go to router 2 and make the RIP administrative distance. You see, RIP administrative distance is 120. I'm going to make it as 100. Router RIP distance 100. This is how we change the administrative distance. After putting this, if you check the routing table, show IP route trip, you will definitely see the routes. You see? You are seeing the routes. Now these routes will be advertised to router 3. Earlier router 3 was going via 4, but now how it is going? Router 2. Perfect. Because of the cost is cheaper now, 20. Going via router 2, cost is cheaper. Now go and check the same on router 8, which is in area 2. Router 8, earlier it was going via 7, but now it is going via 5. It should see, it is going via 5. It is going towards the left. You understand?
Yes, sir.
Okay. We don't want that. We want all the members of area 2 to go towards right, towards R7, not 5. Okay, that's our aim. For that, we want to stop this type 5 coming in from router 5. See, this is type 5. E2 means, E means what? Type 5. We want to stop it. You see, show IP OSPF database can show you that. It is type 5. You see, type 5. We want to stop this, which is coming from router 2. We want to stop this, and we want to have router 7 given type 7. So how do we do that? Simple. Go to all the router in area 2, including router 8, router OSPF 1, area 2 is NSSA. Let me do the same on router 5. Okay, let me finish. Router 7 is ready. Router OSPF 1, area 2 is NSSA. And then router 5. I'm doing this on all routers in area 2. 5, 8 and 7. These are the 3 routers we have in area 2. Router OSPF 1, area 2 is NSSA. Okay. Now if I go back to router 8, which we were using for testing, let's check now. Show IP OSPF database. You should not see type 5 at all. Instead, look at this. What do you see now? Type 7.
Type 7 LS.
And type 5 is gone actually. Type 5 won't be there. See, this is somebody, let's say type 3.
Yes.
Type 7 is totally blocked. And check the routing table. Show IP route OSPF. Even though it is costly to go via router 7, it goes via router 7 and you see N instead of E. N means not so stub area routes. It is going via 7. This is what we achieve using NSSA. If any one route that this cannot give, default route will be used to go there. For that we need to say default information originate always. Yeah, so that you can use the default route to reach the other AS. Now, what next I'm going to do is, I'm going to trace the route and show you once. Trace route 11, 11, 6, 1. It should go to 7 and then 6. it goes to 7. Okay, goes to 6. Done. Now what next is, we are going to do totally not so stub area. See, what is the difference? When I say totally not so stub area, type 3 also won't come, which means these routes won't come. IA. IA means what? Type 3 learned routes, right?
Yes.
IA. Let us do that. Very simple. Go to only ABR. R5 is the ABR here, okay? Go to ABR and say no summary. Previously what we have configured not so stub area, right?
Yes.
To that you need to add no summary. Let me do it. Router OSPF 1. We already configured not so stub area. I remove this. And again I put that with no summary. With no summary. Done. Only on ABR you need to do no summary. All other inside routers should have only NSSA configured. Now let's go back to router 8 and check the routing table. You see, routing table will be very small. Wait. You see, IA, only default route. And local, type 1, type 2. And then N2. So what all you will have? Type 1, type 2 and type 7. Do you understand?
Yes.
Check the database. Show IP OSPF database. See, type 1 is router LSA. Type 2 is network LSA. And then one default route given by ABR. That is the only type 3 LSA summary, the default route. And then you got type 7. Right, even now if you trace route, it should go to router 7. But if there is no path via 7, then it will use the default route and go via 5. Do you understand that?
Yes.
Right side, if there is no path, only then it will take the default route and go to the left side. Yeah? So, we are not compromising here. We are trying to use the local ASBR. If local ASBR don't have route, then it will use the default route to go to the other ASBR which is in another area. Not only that, it's the same default route that will be used to reach other areas. See, it goes to router 7 and then from there to router 6. Yeah, it is 6. Okay. Now what I'm going to do is I'm going to shut down this particular interface on router 6. I want to show you that it can take another path. When there is no route, I'm going to shut down this particular interface IP on router 6, which is RIP on the right side. I hope you are following.
Yes. Yes.
This one, I'm going to shut down this interface. Interface loopback 6, shut down. After I shut down, there won't be route now in type 7. That also I want to show you. Go to router 8 back and check the route show IP OSPF database. You won't have route for 11.11.6, you see. After 5, what is there? 7. 6 is missing. But still I'll be able to ping. It will go via 5 now, router 5 and router 4. You see that it goes to 5 this time because there is no root wire outer 7. So what I'm trying to show you is you have failover. You understood? Maybe you're on mute. See, 5, 4, and 3, 2, 1, it will go. So we have completed not so stub area, totally not so stub area. All OSPF special area type is covered. What next we will get in is we'll get into BGP or ISIS or EIGRP, whichever you like, or anything that you want in our next class. What